All right, another day of computer science. So another lecture, today we talked about counting loops, counted loops, sequence type functions. So sequence dot, say index, sequence dot count, list concatenation, min, max, sum. I think that's most of them. We didn't talk about pop, append, or remove. Then we talked about lists themselves, creating them, with brackets, using index expressions. I missed a question, which was kind of annoying, but basically what I missed was it was 2 while loops back to back, and basically at the end of the while loop it increments the variable, and then it uses that variable in the next while loop expression to check. And basically I forgot to count that last step through increment to the next. So kind of annoying, but it's all right. You live, you learn. I got the quiz 1 grade back, so I'll be checking that later and seeing what I missed. I got like a 23.5 out of 25, so it's all right. We'll see what I missed. It's annoying, but that annoyance is what leads to learning the things I made a mistake on. So sequence type functions, lists, and count controlled variables. Or not variables, count control loops. So yeah, a list is a data container. Sequence functions, not all use dot notation, but some do. And control structures, I believe, refer to cascading if sequences as well as loops. So while loops and while loops and for loops. So that's it for right now. Talk to you later today. See ya. What's up? Welcome back to computer science. What did we do yesterday? Tuples. Name tuples. Okay, so tuple is basically a data container, I believe, like a list, except it's immutable rather than a list that is mutable. And it's denoted using parentheses. And you can denote it as one single string with spaces to separate items or commas. Or you can separate them, I think, as different strings or different numbers, like a list potentially. So named tuple. A named tuple is kind of like a template. It's like a new data type that you create, and it's a template for other tuples. And then, so you create it by saying the name of the tuple gets named tuple, parenthesis, the string of the name, comma, and then basically the list. Right, you can use brackets there like a list, or you can use it as one string, like I said. And then once you create a new, you want to create a new tuple with that structure of the name tuple. Well, you have to actually import name tuple before you can use name tuple, and that is from collections import name tuple. And yeah, when you create a new name tuple with that structure, you're basically gonna give it a name and then assign it a value. And what you're going to assign it is basically parenthesis and then the values. And then if you want to access those specific values, instead of using an index like a list, you say the variable name, or not the variable name, the tuple name dot, and then you say the named tuple parameter or argument or attribute, I should say, the named tuple attribute that is correlated with the one, like the location of the value you want from the tuple you created. So I think that's basically it. Store a collection of data. Immutable, created using parentheses and commas. Printing a tuple always displays the parentheses. Interesting note. Named tuple allows the programmer to define a new simple data type that consists of named attributes. Okay, contains fields such attribute names. Must import name tuple container to create new name tuple or create name tuple, which is from collections import name tuple. Name tuple parenthesis creates a simple data type, not a new data object. Fields can be denoted in a list or single string with space or comma separated values. Okay. That's everything. I'm going to jump back in, continue learning, and then I'll be back to recall what I learned in a little bit. All right, guys, I just took a ton of notes. We are officially into programming in Python. That is a new frontier for me. I've never been working with any of this stuff, so I got a lot of notes to take. This unit was all about sets, okay? Sets. Sets are also a collection of data similar to lists, similar to tuples. What makes them different, though? They're denoted with curly braces to create a set literal. Okay, but that's not the big difference. The difference is sets are unordered collections of unique elements, meaning there are no duplicates, and that there's no index, there's no order. The order doesn't matter. Sets are often used to remove duplicates from lists or other sequence types. You can create it using the set function with a list or a tuple or some kind of sequence type as the argument in the set function, or you can create a set literal, like I said, with curly braces and commas. Okay. Sets. We got set functions. So the add function, so set name dot add, and then as the argument value, that will add a new element to a set. Set name dot remove, and then the argument being the value you want to remove, that will remove that value from the set. If you provide a value that's not a valid value in the set, it will return a key error. Pop, so set name dot pop, no argument, will remove a random element from the set. You can also use len to find the length of the set. Sets are immutable. They are, as we can already see, right, as I just said all that stuff. Then we started talking about set theory operations. So I got through 2, there are 4. Set name or set one dot union, and then as the argument, one or more sets will return a new set with all the unique elements between the sets. Set one dot intersection, and then as an argument, one or more sets will return a new set of elements that are in set one, but also in each of the sets that are denoted or referred to in the or called in the like arguments. To create an empty set, you can just use the set function with no argument, no argument. Okay. I think that's basically everything. Unordered collection of unique elements created using set functions, sequence argument, list, tuple, string. Set literal can be written using curly braces with commas separating set elements. Good. You can create an empty set using set function. Good. Sets are often used to get rid of duplicates from sequence types. Good. Sets are mutable. Good. Add adds an element to a set. Set.add value. Good. Raises key error value isn't found. That's for set remove. Pop and remove an element. Good. Set.remove value. That's where raises key error value is found. Good. Set.pop removes a random element from the set. Good. Other methods. Set.oneUpdate. Set.oneUpdate set2 will take all the unique elements, or take all the elements from set2 and add them to set1. That is elements that are non-duplicate of set1. Set.clear will create an empty set. It will just get rid of all the elements within the set. Set.intersection returns new set of elements that are in set1 and each of the other sets. Good. Set1 union. Set2, set3, ... returns new set of all unique elements between the sets. Okay, so that's everything for today. I will talk to you tomorrow. See ya.